Hello there. Welcome to task 5, wherein it says that we are supposed to write a flowchart. I have converted that into an algorithm and write a C program to compute sin of x using Taylor series, and this is our series. Okay, and we have to compare the result with the built-in library functions and print both the results. So we will look at our series first. So our series is this. Okay. So what is our series property? Series property is, it is a summation series. It has set of successive terms. Each new term is opposite of the previous term with respect to sign. Okay. Then let us look at the value of x. The value of x is accepted in degrees for convenience and converted to radians. So from our basic school math we know that whenever, if at all I want to convert any degree to radian, for example if I have say 60 degree to radian, this is my 60 degrees. So what I simply do is I multiply this by pi, okay, and divide it by 180. So this will be my radians equivalence of say x, which are the degrees. Let us take for example 45 degrees, that I will multiply by pi and whole divided it by 180. So once I do that, I get 0.7853. This is my radians equivalent of 45 degrees. Okay, so what we will ask from the user is, we will ask from the user the value in degrees, and that we will convert that into radians. Okay, that is important because user will have, it's easy for us to remember in degrees than in radians. So once we accept the value, then what we will do, our new value of x will be whatever value of x that we have got, I will multiply that by pi and divide it by 180. Suppose if I now want to convert it into degrees, so what I will do, I will take, if the value is in radians, I will multiply that by 180 and divide by pi. Okay, so this got converted into radians. Okay, my x is in radians. Now what we have to do is, we are supposed to look at how do we calculate these terms. So first, our initial condition of the summation of the series is, the first term is x. Okay, so our sum will be initially x. Now if I stop at sum equal to x, right, for example if I have 45 degrees, that I convert that into radians by dividing it by 180, so I get 0.7853. Now if I stop my sine series here, my sine series will stop at 0.7853. With respect to built-in function, it will have a lot of error. I mean, when I say error, accuracy will be less. So if you generate new terms, the more the number of terms that you are able to generate, we should be able, the result will be more accurate. That's what it actually means. Now if you look at my next term, my second term, if you take my second term will be, since it is a summation of series, will be the previous sum plus my term. So in this case, if you see, my term is negative minus x cube by 3 factorial, which means we will have to first, our initial condition of our term will be If you really understand this, one is we can start with minus, okay, or we can say our term here, what we will do is, because it is a term, we will say minus 1. Okay, so if I say, let us do okay, so let me just find our new term. Our initial sum was, as we saw, was x. Our term will also be x, because we only have one term. In our second term, will be the previous term. First I will multiply it by minus 1, the previous term, whatever is the value. Okay, now if you see, my first value was x, my next value is x cube. So if I start my term as x, right, so what I will do is, my next term will be x into x. Okay, so my next term will be then what? Minus 1 into term which is x, so minus x cube. So I get my new term will be minus x cube, which when I add to sum equal to sum plus this term plus minus, so it will be sum minus term. But our issue is, how do I get this 3 factorial and 5 factorial, etc. So if you look at my factorial, what is my 3 factorial? My 3 factorial is 3 into 2 into 1, which is nothing but 6. My 5 factorial is 5 into 4 into 3 into 2 into 1. This also you have 1. My 7 factorial, if I take my 7 factorial, my 7 factorial is again my 7 into 6 into 5 into 4 into 3 into 2 into 1. But if you see, there is some commonality between this, right? 3 into 2 into 1. If you see, 5 factorial also has 3 into 2 into 1, correct? Extra is 5 into 4. And 7 factorial also has 5, 4, 3, 2, 1. Extra is 7 and 6. Okay, so what we could do is, we could initially start with our value. We will have one more value called I, which will initialize to 1. So our first term will now be, what I need is, I need to just get 3 into 2. So if I want to get 3 into 2, which is 6, I should be fine. So what I will do is, I will say 2 into I will be 2 into I plus 1. Please listen to this carefully. So now if you take my I equal to 1, so my I is 2 into 1, which is 2. 2 into I plus 1 means that is 3. My 2 into 3 is 6, which is nothing but factorial of 3. Okay. Now then what I do is, this is the term that I have calculated. Okay, this is my term for the first time. Okay, and my sum will be equal to x for the first time. Then I will calculate my term for the second time, new term, and then I will add this to my new sum will be my previous sum plus the term. Okay, this is for the second summation. Alright, so now if you again if you go to the summation for the third time, so let us do it for the third term. So what is my third term? My third term was x cube by 6, correct? So when I said this, it was x cube by 6, so this term was x cube by 6. So this was my x into x into x cube whole divided by 6 it was. So I'll just keep it as it is. Now my value of I will increment to by 1. So my I will be equal to I plus 1. Now if you look at this, my I is 2. So 2 into 2 is 4. Correct? Then my I, since my I is 2, 2 into 2 is 4 plus 1 5. So 5 fours are 20 into 6 is 120, which is nothing but factorial of 5. Isn't it? So our problem is solved, right? Similarly, if I again do for the third term, it is minus, again I'll do my, now last time it was, my term was minus term, correct? So this was my minus into minus 1, because it was minus 1, minus term, correct? So this was my minus 1 term. So now minus 1 minus and minus become plus. So my third term, if you look at this, this is plus x to the power of 5 by 5 factorial. So this and this will become plus. This is x to the power of 5. This is my 4 into 5 is 120 into 4 into 5 is 20 into 6 is 120. So this becomes my factorial of 5. So I'll get x to the power of 5 by 5 factorial. So if you trace this program, you should be able to figure out. You should be able to get that. Hope you have understood. If you have not, again go back, rewind. That's the beauty of videos, and again slowly learn, right? So let us go back to straight away the algorithm. So what do we do in the algorithm? So in the algorithm, our first step is step 1, as usual, start. Step 2, accept x in degrees. So there are 3 ways of handling it. Either you can ask for the number of terms, or you can also ask for the accuracy. Okay, so we'll ask for number of terms. More the number of terms, more will be the accuracy. So what I will do is step 4, I will start initializing. So before that, step 4, my x will be equal to x into pi, which is 3.1415932 if to be precise, by 180. So that is my x, right? So then what I do, my step 5 will be sum equal to x. My step 6 will be term equal to minus 1 into x. Okay, what I'll do is in the beginning I'll say simply my term is equal to x. So then we will see. So my step 7 is for my I equal to 1, my I remains less than n, I plus plus. So why did I take I equal to 1 already? Because I've already taken sum as 1, correct? My sum is basically already I've taken the first value itself of 1. That's why I'm starting from I equal to 1 instead of I equal to 0. It will also help me to calculate my term. So what is my new term? My new term is, I will now say my term is equal to minus 1 into term into x whole divided by 2 into I into 2 into I plus 1. This is what it is. Okay, and then my sum will be equal to sum plus term. Finished. Okay, simple algorithm. Then print sum. which is nothing but my sine series. Okay, so now what we will do is we will write the program. Hope you have understood this logic. It looks pretty simple. Of course, we'll have step 8 as a stop. Okay, please go through it once again so that you will be able to write down. So let me just start with the program. Hash include stdio.h. So I will take my double, my sum, my x. Okay, then I need also the term. These are my double. My I will be integer. Okay, so then I'll have int main. Okay, I will ask the user printf enter the value of x in degrees. Okay, so here once we accept this scanf percentage d and of, we are accepting x. Okay, so what we'll do is we will store our x in y. In the end we may need it, so I'll also have y here. So now what I will do is I will take my x is equal to x into pi 3.1415932 whole divided by 180. This is my x. Okay, so now what I will do is before I code this program, I will simply use this and see what is the result of the built-in function. The built-in sign of percentage LF is percentage LF. So what is my percentage LF? I'll take y, which is my, I'm giving it in degrees, but I have to call the sine function in radians. It will not accept in degrees, otherwise you will get a wrong answer. We will see. Okay, so this is my sine of x. So my sine of x is there in my hash include math.h. math.h. Okay, so our sine series program is ready. Hopefully that we will just find out what is the value of when we give it in degrees, so that it's easy for us to compare. So we'll do the GCC sine series.c. So I think we have made as file name here sine series.text. That's the problem. I have to save it as .c. Okay, simple. So I'll just say .c. Saved it. So hopefully we should not. Okay, so error sign of using Taylor approximation. So maybe we would have here, there may be some issue. So we have started with this comment and we should have ended it here. Hopefully that may be the error. Let us see. Wow. Okay, so we will remove these things from here. Let us see. So this should be fine. So I have sine series. So this is hash include. Okay, looks to be fine, but let us see. We have saved it. It says y incompatible argument. Okay, all right. So we had scanf. Oh, this is the problem. We're supposed to give LF, right? So that is one. That's not one error. So several errors. I'm just trying to debug it. So it says okay, so we have and of x double sine of x. So here is the error. So let me save it first. So we will get Did we do this? Y is equal to X. Warning, missing terminating character. Where is that? Oh, here. God. Okay, so alright, so we have no errors. Let us compile this program now. Minus O, OP, sine series, OP. So we will give value of 45. So it is giving us sine of 45 is 0.70107. We will take the calculator also. We will say 45 sine. So both the calculator and computer are correct. Only our program has to be correct, right? So our program can be straight away correct if I say printf. I can say the sine of percentage LF of calculated by program is straight away I can say a sum. Okay, so this is the beauty of. So I'll simply initially I'll say sum equal to X. Since I have converted that into radian, so let that be. Okay, so I will do this to the OP. I give 45 if you see. Okay, so if you, wow, not bad. So it's straight away giving us the direct value. Sine of 45. So I was supposed to take here Y. Okay, this should be, oh I'm sorry, this should be Y and then it should be sum. Okay, small goof up there. So we have OP, so we give 45 degrees, so sine of 45. So calculated by the program is 0.78, that is 0.70. So you may say what difference it makes if it is 8% error. No, we have to get exact value, okay, accurate value. Now that is because we have to have number of terms now, because we also have to accept the number of terms from the user. So what we'll do is we'll ask the user the number of terms. We have converted. After this we'll ask the number of terms. You have to be careful for the number of terms, because the factorial will go beyond, say if you take 8 factorial or 10 factorial or 20 factorial or 20 terms. So the factorial may exceed the integer range, so you may get errors there. So maximum we can look at 5. So maximum number of terms. Okay, so we will make this as n. So we'll do the percentage D and of n. So this we also have to give an n here. That's the number of terms, right? So what we will do is we'll just put it in the loop so that you will know how this value finally coincides with that value. So for I is equal to 0, no 1, I less than n, I plus plus. You know why we did that? Because our sum initially is x, right? So that is the reason we do that. So we'll get the sum here. So our sum is x, our term is also x. Is also x. So inside this loop we will put this. So we'll put this loop, wherein in the loop we will do my sum is equal to, before the sum my term is equal to minus 1 into term into x into x. Now this has to be, we have to be very careful. Whole divided by, it's not Baud norm, it follows precedence of the operator, precedence of operators. 2i into 2 into I plus 1. Okay, this should be fine, right? So we will see if there are no syntax errors, how this sum actually start nearing to our sign of sum. Okay, so let us save this and do the GCC. Okay, no problem. We'll give 45. We'll give 5 terms. That's more than enough. Okay, so Oh, did we do the sum equal to sum plus term? See, we have not done that. So 0.78, it is not changing. So no need to panic. I'll just do sum equal to sum plus term. So now you know the importance of term, right? So we'll go back, do the OP. So we have 45 degrees. We'll give 5 terms max. Perfect. See, only in the third term we are able to get this value. Okay, so there is no need for us to put this in the loop. We can actually say that we will say that this is the value of sum calculated by the program is this. Then let us see. Yeah, the error difference is 0. Okay, so we can take other values as well. So we will do one thing, we will take different values. OP sine of 90. Okay, we'll have 5 terms. Sine of 90 is 1, so we are getting 0.1004. Maybe we can increase the number of terms. I told you there is a problem here. We have to have the number of terms. Now if I make the number of 10, so it may go for getting error difference is 0, right? So we are there, it is working perfectly fine, right? So hope that you understood this logic. This I have only made to see the error difference between our sine of x minus the sum. So that was the whole idea. Okay, so hope that you understood this code. Please, if you have not understood, go back to the video, rehearse it properly, and then we will take it forward from there. Okay, so thank you very much. See you in the subsequent videos. Goodbye.